All right, hello everyone. Welcome to my first digital screencast for Module 11 for EDU 210 based on the maker movement and education. This week we were able to attend a mini maker fair at the university hosted by Tech and Ed in collaboration with other tech startups and educational facilities. Maker fairs, so you'll see on your screen here, I have it open to the Maker Faire website. Maker fairs like the one at the university are held all over the globe and are focused on inspiring future innovators. There's also heavy emphasis on collaboration and building off of existing technologies and projects in open source communities such as Instructables and MakerBot Thingiverse. To give you a bit more background information about the maker movement, it was originally started by hackers, inventors, and educators who noticed that there was a large spread and increased accessibility to and affordability of constructive technology, in part brought about by access to information on the internet, as well as constructive technology just becoming cheaper. So this plays really well into the learning educational theory of constructivism, which focuses on active project-based learning that takes place with a real-life social context. So to kind of show you guys a document that kind of outlines this. This document is from the International Society for Technology and Education, and it outlines a number of ways through which the maker movement can be used in classrooms to increase effective learning. Personally, I think I learn best by doing, and I benefit more from practical learning with real-life applications than I do from theory. The maker movement definitely plays into this, and it centers the learning around the learner and bases projects off their personal strengths and interests. The other thing that I really like about the maker movement is that it focuses on the student as the innovator and the creativity of the student as innovator. It's really important because these kids that we're teaching are going to be the leaders of tomorrow, so if we're not sparking that interest in them, maybe they won't be interested in their future. So yeah, at the Maker Faire, I explored 3D printers and 3D pens, as well as Little Bits and Makey Makey. While I think Makey Makey and Little Bits can be geared towards younger students as well as older students, the 3D printers and 3D pens were definitely something that I thought I could use in a high school science classroom. The 3D printer exhibited by Tech and Ed was a MakerBot replicator model. I do have a video and some pictures attached to my ePortfolio of the MakerBot replicator model if you're interested in checking those out. So these devices, this is the MakerBot, I guess, guide to how it works. Yeah, it's a really cool document to check out. The website's up here if you're interested in looking at more information about how it actually works. But to give you guys a quick version of it, basically they work by taking a digital design of a 3D model and it sections it out into smaller printable chunks. The device then lays down layer after layer of molten plastic to create a 3D version of the object you designed. You can also create larger objects by printing them in smaller components. And like the capacity for the size depends on the model, but MakerBot, I think one of the biggest replicator models, you can now make something that's about the size of a shoe. So just to give you guys a guide for the size of it. So to show you how you can print a larger object in smaller parts, this is something on Instructables. So Instructables is an open educational resource. So this guy here has actually outlined a bunch of steps that you can take to take an MRI of your brain and print out a 2-scale model of your brain. So that's really cool. So this model, if you had a larger MakerBot printer, you could probably print it like he did, which was just hemisphere by hemisphere. But if you didn't want to print it in 2 parts and you wanted to make it more like a model, that fits together so you can see the interactions of different areas of the brain, you could print it in as the different lobes of the brain and then put them all together at the end. You could even print them in different colors and stuff like that, so it's really easy to take apart and fit them back together and kind of see how everything works together. So definitely something that would be totally applicable to a biology classroom. The 3D printer was a great example of ways that students could engage in learning, both collaboratively and in a real-life context. Students can download templates and project ideas from either Thingiverse or Instructables and modify them for their own use. I would have students use the MakerBot to create their own 3D cell models, such as these examples here that I'm going to show you. So it's very, very similar to the brain that I had just showed you, but this one is an animal cell, so you can see it's probably been printed in one piece. This one is quite small, but you could also print it larger and print out each of the different components of a cell in a different color and make it, you know, quite a large scale model. And the second one, this guy made a plant cell, and you can see that he printed all the different components separately and then fit them all together. So this is something that I think would be a great activity for students in the classroom, because not only does it give you experience programming and designing on a computer and coding, but it also gives you a learning opportunity in biology, so you can see how things function together a little bit better. So all of the models and materials that I showed you on both Instructables and on Thingiverse are available through a Creative Commons license, so it's super easy for students to take models and then build on them to make it their own. So just to finish up here, a few weeks ago I was shown a TED Talks video created by educator Cesar Hirata at the Harbor School in Hong Kong. The Harbor School holds a citizen science-based approach to science class, so in order to better facilitate real-life learning context, Cesar and his colleagues made a lab for students to build and create their own projects to try to find solutions to real-life problems. So for example, in this video, they talk about oil spills, and they also talk about possible radiation from Fukushima. So because they could see like little bits of plastic washing up on the beach close to their school, the kids are really interested in like what's in the water. So they took it and turned it into a learning opportunity, and it's this huge thing now. So definitely check out this video. The link is up above if you're interested in it, and I will also post it on my ePortfolio. So to apply this to my potential future classroom, for a water conservation project, students could use the 3D printer to print components for a robot, to test water samples for microorganisms and the amount of algae and bacteria per cubic liter, or even just to collect water samples for further testing later on. To me, this is the possibility of the maker movement. We are educating the leaders and inventors of tomorrow, and if we can get them interested in finding creative solutions to a very widespread variety of problems, they will hopefully become passionate enough to continue innovating and trying to build a better future. Yeah, so really great stuff. It's not only constructivist in nature, but it also has the possibility to be a social reconstructivist form. So these kids can change the future if we give them the tools and the get them to believe in their own capabilities. So the maker movement really does hold a lot of potential. Thanks, guys.